Hello viewers, welcome back to my YouTube channel. Today I'm going to explain the factorization of polynomial. That is an introduction to factorization in the polynomials, which is chapter 2 of polynomial class 9 NCERT mathematics. So I'm going to explain factor theorem with proof and examples, and we'll do a couple of exercise problem of 2.3. Uh, Let us explain the meaning of factor theorem. So this is the definition and you need to prove this. Very simple. If p of x is a polynomial of degree n greater than 1, we know already that n should be greater than 1. So if p of x is a polynomial of degree n greater than 1, a is any real number, then you need to prove these two. X minus a is a factor of p of x if p of a is 0. If you substitute p of a is equal to 0, if it will come x minus a, then it is a factor of p of x. In converse, if p of a is 0, then x minus a is a factor of p of x. So these two are converse to each other. So let us prove. We know that remainder theorem says if p of x is a polynomial, p of x is equal to x minus a into q of x plus p of a. So here p of a is a remainder and q of x is a quotient and this is a factor. So this is the theorem which given by remainder theorem. For the first case, if p of a is equal to 0, substitute a is equal to 0 in this equation, then it will become x minus p of a is 0, then the second term get cancelled. The remaining thing is x minus a into q minus x. So we can say x minus a is a factor of p of x. Again, since x minus a is a factor of p of x, then p of x is equal to x minus a into g of x for same polynomial g of x. So if you substitute the value of x minus a and again 0 for p of x, then it will become 0. Again, it's a converse to the first theorem. I hope all of you understood this, and we have already come across zeros of a polynomial. These two concepts we have already learned in zeros of polynomial. Based on that theorem, we can state the factors theorem. Let us take one example here. Examine whether x plus 2 is a factor of the first polynomial and the second polynomial. Let's take the first polynomial of p of x is equal to x cube plus 3x square plus 5x plus 6, and the second polynomial as q of x is equal to 2x plus 4. So these are the two polynomials which they have given, and you need to check whether the given factor is a factor of these two. So given x plus 2, and we know already to becomes a 0 or to become factor, it should be equal to 0. It becomes x is equal to minus 2. So substitute the value of x is equal to minus 2 in both the equations. If it comes 0, again we can say that the given factor x plus 2 is a factor of x plus x cube and the first polynomial and the second polynomial. Substitute the x is equal to minus 2 in the first equation. We'll get minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. So this is, so minus 2 into minus 2 into minus 2. So there are three multiplying minuses are there. The answer would be minus. So 2 cube is 8 plus 3 into minus 2 is plus 4. Here minus 5, 5 into minus 2 is minus 10 plus 6. So it becomes minus 8 plus 12 minus 10 plus 6. So 12 plus 6 is 18, minus 8 minus 10 is minus 18. It becomes minus 8 plus 18. Minus 18 plus 18 becomes 0. So p of minus 2 is 0 for the first case. Similarly, substitute x is equal to minus 2 for the second polynomial. It becomes like this, minus 4 plus 4, and it becomes 0. So we can say x plus 2 is the factor of both the polynomials p of x and q of x. So just substitute the value of factor in the given equation. If it comes 0, then it is a factor for the polynomials. So there is one more problem. You need to find out k value here, and they have the factor is given. You know that x minus 1 is equal to 0, x is equal to 1. Substitute x is equal to 1 in the following equation. you'll get p of x is equal to 4x cube plus 3x square minus 4x plus k. So what it becomes is you substitute the value of 1 here, and again there is you need to find out the value of k. Substitute p of x is equal to 0 in the left hand side. So first substitute p of 1 here, 4 into 1 cube plus 3 into 1 square plus 4 into 1 plus k. It becomes 4 plus 3 plus 4 plus k. So it becomes 11 plus k. So here, by the remainder theorem, you need to find out the value of k. Substitute p of 1 is equal to 0. It becomes 11 plus k is equal to 0. K is equal to minus 11. I hope all of you understood this. It's very simple. You need to put the given polynomial and equate to 0 to find out the value of the given variable. Let us start with exercise 2.3, question number 1. They have given a factor, that is x plus 1. You need to find out whether the given factor, the given value of x will become a factor of the polynomial. So substitute p of x is equal to x cube plus x square plus x plus 1, and here x plus 1 is a factor they have given, equate it to 0. It becomes x is equal to minus 1. Substitute minus 1 here. P of minus 1 is equal to minus 1 cube plus minus 1 square plus minus 1 plus 1. So minus 1 cube is minus 1 square is plus 1, minus 1 plus 1. So it becomes minus 2 plus 2, and both will cancel, it becomes 0. So given x plus 1 is a factor for the polynomial. The second problem, p of x is equal to x to the power of 4 plus x cube plus x plus 1. Substitute x is equal to minus 1 because the same factor for the two problems. Minus 1 to the power of 4 minus 1 cube minus 1 plus 1. So since it is the power 4 and the negative sign multiplies 2 times and it becomes positive. This is 3 times odd number, it is negative, again negative plus positive. Here also 2 minus 2, it becomes 0. So x plus 1 is a factor for both the polynomials. It's a factor for both polynomials. So this is the answer for this question. I hope all of you understood. We'll take up the next one. So p of x is equal to x power 4 plus 3x cube plus 3x square plus x plus 1. So here also x plus 1 is equal to 0. Substitute x is equal to minus 1. P of minus 1 is equal to minus 1 power 4 plus minus 1 power 3 plus 3 into minus 1 square plus minus 1 plus 1. So again, fourth power, it's a positive one, and here minus 1 into minus 1 into minus 1 becomes minus 1. Minus 1 into plus 3 is minus 3. This will become plus 3 minus 1 plus 1. So what will happen here? 1, 3, 1. It becomes 5. Again, negatives, minus 1, minus 3 and minus 4 is minus 1 is minus 4. Answer is 1. 1 is not equal to 0. Therefore, x plus 1 is not a factor in this case. For the third sub problem, it is not a factor. Since it becomes 1, you can say it is not a factor. So this is the problem number 3. Let's take the problem number 4. So p of x is equal to x cube minus x square minus 2 plus root 2x plus root 2. Substitute p x is equal to minus 1. It becomes minus 1 cube minus 1 square 2 plus root 2 into minus 1 plus root 2. So you just substitute the value and simplify. So this becomes minus 1. So again it's plus 1. Again it is minus is there. Minus into plus is again minus. Minus of Minus 1 into 2 is minus 2. Minus 1 into root 2 is minus root 2 plus root 2. So minus 1 is minus 2. Again minus into minus is plus 2. Minus into minus is plus root 2 plus root 2. So it becomes, again you can say, so minus 2 and plus 2 get cancelled here, and the remaining thing is root 2 plus root 2. There are two times of root 2 is there, that is 2 root 2, which is also not equal to 0. Therefore x plus 1 is not a factor in this case, not a factor for the given polynomial. So you need to simplify, all the viewers, you need to simplify and take a workbook and solve this, because all the negatives and positives sign you should be very careful, otherwise your problems leads to a different answers. So you can lose your marks if in that case. If you have any doubts, you can just leave a message in a comment box. I'll try to figure it out. uh, so don't forget to like, comment, share and subscribe. Thank you.